Bismillahirrahmanirrahim. Assalamu alaikum, dear student. Today we will start new syllabus Mathematics D2, chapter number 1, Direct and Inverse Proportion. Exercise 1D, intermediate level, question number 3 to 8. Now, in question number 3, for each of the following equations, state two variables which are inversely proportional to each other and explain your answer. So, here A, B, C, D and E parts are given in which two variables which are inversely proportional to each other. We can explain and write the answer. First of all, solve the A part. If y is equal to 3 upon x square, we know that y is equal to k upon x square. Now comparing both equations and find the value of constant k. On comparing, k is equal to 3. Therefore, y is inversely proportional to 1 upon x square. Here, in this part, y is inversely proportional to x square. In B part, if y is equal to 1 upon x square root, and we know that y is equal to k upon x square root. In both equations, we can compare and find the value of k. Now, on comparing, k is equal to 1. Therefore, y is inversely proportional to 1 upon x square root. In this relation, y is inversely proportional to square root of x. So we can write that in mathematical form, y is inversely proportional to x square root, or in simple we can say that y is inversely proportional to square root of x. In next C part, if y square is equal to 5 upon x cube, we also know that y square is equal to k upon x cube. On comparing and find the value of k is equal to 5. In both equations, we can compare that k is equal to 5. So we have y square is inversely proportional to x cube. Y square is proportional to 1 upon x cube. In this relation, y square is inversely proportional to x cube. In D part, n is equal to 7 upon m minus 1. We know that n is equal to k upon n minus 1. Now comparing both equations, k is equal to 7. On comparing, k is equal to 7, therefore n is proportional to 1 upon m minus 1. This relation shows that n is inversely proportional to m minus 1. In last part, E part, Q is equal to 4 upon P plus 1 whole square root. So, we know that Q is equal to K upon P plus 1 whole square. On comparing both equations, K is equal to 4. Now on comparing k is equal to 4, therefore q is inversely proportional to 1 upon p plus 1 whole square. Or we can also say that q is inversely proportional to p plus 1 whole square. In question number 4, z is inversely proportional to cube root of x and z is equal to 5 when x is equal to 64. Find the value of z when x is equal to 216. First of all, according to given condition, Z is inversely proportional to cube root of x. So Z is proportional to 1 upon cube root of x. Now this implies that Z is equal to k upon x cube root. Now finding the value of x when Z is equal to 5 and x is equal to 64, we can find the value of constant k. Putting the values in given relation, value of z is 5 and value of x is 64. This implies that 5 is equal to k upon cube root of 64. Taking the cube root of 64, that is equal to 4. 4 is multiplying on other side. This implies that k is equal to 5 multiplied by 4. 5, 5 4s are 20. Now we can find the value of z when x is equal to 216. Here z is equal to 20 upon 216 whole cube root. Now first of all taking the cube root of 216. 216 is a cube root of 6. This implies that z is equal to 20 upon 6. Now dividing the 20 by 6 is equal to 3.33. So the value of z is equal to 3.333. Now we can find in question number 5, q square is inversely proportional to p plus 3 and q is equal to 5 when p is equal to 2. Find the value of q when p is equal to 17. First of all, according to given condition, q square is inversely proportional to p plus 3. Now we can write that q square is proportional to 1 upon p plus 3. Removing the proportionality sign, use a constant, then this implies that q square is equal to k upon p plus 3. When p is equal to 2 and q is equal to 5, find the value of constant. Putting the values in given relation, q is equal to 5 and p is equal to 2. This implies that 5 square is equal to k upon value of p 2 plus 3. 2 plus 3 is equal to 5 and 5 square is 25. Now 5 is multiplying by this side, so this implies that 25 multiplied by 5 is equal to 125. So the value of k is 125. Now we can find the value of q when p is equal to 17. This implies that q square is equal to k upon p plus 3. Putting the values, this implies that q square is equal to value of k is 125 upon value of p 17. So 17 plus 3. First of all, added 17 plus 3 is equal to 20. This implies that q square is equal to 125 divided by 20. Now 125 divided by 20 is equal to 6.25. So the value of q square is equal to 6.25. For removing the square root, now taking the square root on both sides. Q square whole square root is equal to 6.25 whole square root. Square cancel out by square root, so Q is equal to plus minus 2.5. Now the value of Q is equal to plus minus 2.5. Now move in question number 6. Given that T is inversely proportional to X cube, copy and complete the table. Here table is given. We can find the value of remaining S and Q. Now, first of all, according to given condition, T is inversely proportional to X cube. T is proportional to 1 upon X cube. Removing the proportionality sign, this implies that T is equal to K upon S cube. First of all, find the value of constant. Here S is equal to 1 and T is equal to 80. Both values are given, we can find the value of constant. Now when S is equal to 1, T is equal to 80. Find the value of K, putting the values in given relation. This implies that 80 is equal to K upon 1 cube. 1 cube is also equal to 1. This implies that K is equal to 80 multiplied by 1. 80 ones are 80. So this implies that K is equal to 80. Value of constant K is equal to 80. Now we can find the remaining value. In first part, S is equal to 2. Find the value of T. If S is equal to 2 and T is equal to question mark, this implies that T is equal to 80 divided by 2 cube. First of all, taking the cube of 2, 2 cube is equal to 8. This implies that T is equal to 80 divided by 8. 80 divided by 8 is equal to 10. So the value of t is equal to 10. In this part, value of t is equal to 10. In second part, s is equal to 4. Find the value of t. Now, s is equal to 4. T is equal to question mark. This implies that t is equal to 80 upon 4 cube. First of all, taking the cube of 4. 4 cube is equal to 64. This implies that t is equal to 80 divided by 64. 80 divided by 64 is equal to 1.25. Now in part C, t is equal to 0.08 and s is equal to question mark. This implies that 0.08 is equal to 80 upon s cube. S cube move on other side and 0.08 divided here. This implies that S cube is equal to 80 divided by 0.08. Now 80 divided by 0.08 is equal to 1000. This implies that the value of S cube is equal to 1000. Taking the cube root on both sides, so s cube whole cube root is equal to cube root of 1000. Now s is equal to 10. So the value of s is equal to 10. Cube root of 1000 is equal to 10. In next and last part, t is equal to 0.01. Find the value of s. This implies that 0.01 is equal to 80 upon s cube. S cube move on other side and 0.01 divided by here. This implies that s cube is equal to 80 divided by 0.01. 80 divided by 0.01 is equal to 8000. This implies that value of s cube is equal to 8000. Taking cube root on both sides, s cube whole cube root is equal to 8000 cube root. Taking the cube root of 8000, this implies that s is equal to 20. So the value of s is equal to 20. In question number 7, the force of repulsion F Newton between the two particles is inversely proportional to square of distance d into meter between the two particles. Now We can write the formula of connecting F and D, and in second part, when the particles are certain distance apart of the force of repulsion is 20 Newton, find the force of the distance is half. Now we can find the solution according to given condition F is inversely proportional to D square. We can write that F is proportional to 1 upon D square. Removing the proportionality sign, this implies that F is equal to K upon D square. Here the value of K is a constant. So we have if F is equal to 20 centimeter and D is equal to X. Now we can find the values. 20 is equal to K upon X square. Here X is the distance D. So D is equal to X. We can putting the value of D into X. So value of F is 20 is equal to K upon X square. X square move on other side. This implies that constant K is equal to 20x square. Now we have D is half, distance is half, so D is equal to 1 upon 2x. Distance is half of the first distance. D is equal to 1 upon 2x, find the force. So F is equal to value of K 20x square upon value of D 1 upon 2x whole square. 1 upon 2 square is 1 upon 4 and x square is x square. X square cancel out by x, so this implies that F is equal to 20 multiplied by 4. Now the value of force is 80 Newton. The final answer of force of repulsion is 80 Newton. Now in last question of intermediate level, we can solve for a fixed volume. The height h of a cone is inversely proportional to square of base radius. Cone A is a base radius of a 6 centimeter height and the base radius of base cone B is 3 centimeter and the height of cone C is 1.25 centimeter. If all the cones are same volume, find the height of the cone B and the base radius of the cone C. Now, first of all, according to the question, according to given condition, F H is inversely proportional to R square. So H is equal to 1 upon R square. This implies that H is equal to K upon R square. Here K is a constant. So H is equal to 5 and R is equal to 6. Find the value of K. This implies that 5 is equal to K upon 6 square. Taking the square of 6, 36 and 36 is multiplying on other side. This implies that K is equal to 5 multiplied by 36. 5 multiplied by 36 is equal to 180. This implies that K is equal to 180. In first part, if R is equal to 3, find the height of cone B. In cone B, in first part, the radius of cone B is 3. Find the height. This implies that h is equal to value of k 180 divided by r square, 3 square. First of all, taking the square of 3 is equal to 9. This implies that h is equal to 180 upon 9. Now dividing the 180 by 9 is equal to 20. Now in second part, find the base radius of cone C. If h is equal to height is equal to 1.25, find the base radius or d. Now we can find the base radius. H value of h is equal to 1.25 is equal to 180 upon d square. This implies that d square is equal to 180 divided by 1.25. 180 divided by 1.25 is equal to 144. This implies that the base radius d square is equal to 144 taking square root on both sides. D is equal to 12. So the base radius of the cone C is 12. Best of luck in next video with next lesson. Take care.